Hi, my dear student friends. Welcome to ACE Engineering College YouTube live session, which is meant for revision series of university examinations. This session is for revision of previous year questions of university examinations. The students who are preparing for university examinations, this session will be definitely useful to you. Right. So in this session, I am going to teach a topic that is Laplace transform. So this is one of the topic in engineering mathematics. Okay. So in this Laplace transform, the previous year's questions which are asked in which are asked in university examinations, we are going to discuss. It's totally whatever the problems I am discussing here, which are previous university examination questions only, okay, which are taken from previous question papers, right? See contents of the topic here. So introduction of Laplace transform and applications of the Laplace transform, and definition of the Laplace transform of the elementary functions, properties of Laplace transform, and inverse Laplace transform, solving differential equations. So these are the topics I am going to cover. So these are the topics under Laplace transform, of which solving differential equations is very important. 100% one question is coming from solving differential equations. Okay, solving differential equations is a connection of inverse Laplace transform, and solving differential equations means we are going to solve the differential equations using the properties of Laplace transform and formulae. That formulae is from Laplace transform of elementary functions. Okay, means these are you need to learn for solving differential equations. Actually, these are developed from definition of Laplace transform. Basic is definition of Laplace transform. If you know all these topics one by one, you can easily solve this. That's why I am just listing the topics in a Laplace transform. And why I am introducing application, why I am giving introduction part and application part, because it's a session for revising previous questions now. Why I am giving introduction and application part? You should know about the topic before going to enter, before going to learn a topic. You should know about it, its background and all, and its applications. Then you feel interest about to learn, right? And you should know the applications. Then you feel, you show interest. It's make enthusiasm to learn about, right? So these are the contents. Next. So introduction, small, just I'm not getting into in-depth. I'm not going to give in-depth of introduction part, just small brief on introduction part, right? So this is Laplace transform is a integral transform, okay, integral transform, which is used to switch a function in real variable, that is T domain, into a function in S domain, that is in complex. Means T domain to complex domain, we are switching a function. Why we are switching into? To analyze more easily. To analyze more easily about the functions we switch into. That is done by Laplace transform, right? See, you see this diagram, data is available like this. I am applying Laplace transform, and this data is convertible into linear. It is in non-linear form. The data is in non-linear form. I am converting into linear, so that you can draw the results, you can draw the conclusions, you can evaluate the values more easily. In that sense, Laplace transform is much useful, right? Next, So this is a short video. I want to show how Laplace transform works behind the system, right? So this is the calculus. Most of the students, they are scared about learning calculus. Yeah, most of the students we are facing, they're scared about its applications, about evaluations using calculus. Okay. But in engineering mathematics, without calculus, we cannot. So using calculus is very essential. It's a part of engineering studies, right? So we are introducing algebraic to eradicate the difficulty. In calculus, whatever the difficulty you face, we can eradicate it by algebraic. How that is happen means, see, I am taking the data from calculus, taking Laplace transform tool, converting into algebraic. So whatever the data available in calculus, I am converting into algebraic by using Laplace transform. It is a non-linear form. If the data is in non-linear form, if I convert into algebraic, it is easy to analyze, it is easy to observe the things, it is easy to evaluate, right? Now I will show here a small video how that data is converged into algebraic. The calculus is converged into algebraic, how the data is in calculus, and when it is converged into algebraic, how it becomes. A small video I will show. So it's a just introduction part. I will make it small, brief. That's it. See, this is the data. This is the data in calculus. Data is like this. When I look into the data which is in calculus, when I look into what I face, the clumsy, see here, the clumsy atmosphere I can look on. Okay, so in zigzag manner, it is mesh, the data in mesh. Okay, so in such cases, how I draw the conclusions, how I draw the results, how I evaluate. So what I am doing now here, just I am converting into linear. See, the data is converting into linear. See, by applying Laplace transform, this calculus data is converting into linear. Right? The data is converting into linear. So we can have clear picture about the data. And at any instant we can speak about the data. So in that sense, Laplace transform help us to draw a better results in easy manner. Means complexity to a simple through Laplace transform. Right? This is one application. Next. See here, one more concept, means one more thing I want to introduce here. This is a complex machine, which is an inbuilt of a complex machine, in which a lot of complex operations we have to perform, we have to operate to perform a machine. Okay, so to perform a machine under inbuilt, you have to apply some control system. You have to operate on control system. That control system analyze the behavior of the condition of the system. Means behavior and under different conditions how it is behaving. Okay, so that we learn under control system. But this control system are governing by certain equations. Okay, machine is operating using control system. Behind control system, some equations are governing. the solving equations directly, such equations cannot be solved directly. Solving equations must to operate a machine. Okay. So to solve certain equations is not possible, highly difficult. In such case, we transform that certain equation into frequency domain, we operate the complex machine, right? So this makes very awesome tool, Laplace transform. Even bigger size machines can operate very easily behind Laplace transform applications, right? So most of the engineers and physicists, mathematicians, astronauts, most of the anyone who are working in complex field, they will definitely approach Laplace transform, right? Next, applications, evaluating improper integrals. Proper integrals itself we are facing a lot of difficulty to evaluate, but in case of improper integrals, definitely you face a difficulty. That we do simple using Laplace transform. What is one application? Next, solving differential equations that I have shown that in previous slide. Solving differential equation by transforming into algebraic. It is simple. So that is what I am showing on the diagram. See, this is a real world problem. This is a real world problem. See. So this real world problem is nothing but differential equations like calculus. In case of calculus I am saying. In the calculus field, differential equation I am taking, or improper evaluation of improper integrals you take. So this differential equation I am transforming into algebraic. Means that clumsy or difficulty I am converting into algebraic. Means in simple, in linear. So then by using certain initial conditions, I am evaluating the solutions using through inverse Laplace transform. Okay, so like that. Next, to analyze and design the circuits. Okay, where clumsy circuits system is there, in such case analyzation is better possible using Laplace transform. Next, signal processing. Nowadays signal processing is an essential part in our communications, in communication system. That signal processing is handled smoothly, simply through Laplace transform tool. And biomedical engineering. In biomedical engineering, how the behaving biological system, we can observe easily, how means we can draw the analysis by observing biological system through Laplace transform. These are the applications under Laplace transform, right? Next, definition means this is the basic thing before going to Laplace transform. Definition of Laplace, basic means this is the base to develop. Further development is happening. This is f of t, a function in t domain. Means I am applying Laplace transform in a function of t domain and converting into a function in S domain. So in t domain, function faces some difficulty. To make simple, I am applying Laplace transform that converts into a function. Yes, where comfortable to evaluate, where you feel comfortable to do so, to do the works, to perform the things, right? So that is happened by using integral, by using what? By using integral transform. This is integral transform. Integration 0 to infinite e power minus st f of t dt. Okay, so if I evaluate this improper integral, I can get a result in terms of s, that is f bar of s. Right? This is a definition of Laplace transform ask for the short answers. For the short answers they are asking in the university examinations, you better have a look on it. Right? Next, sufficient conditions for existence of the Laplace transform. So you have to check Laplace transform exists for the functions or not, right? So those are piecewise continuous functions, and second one is exponential order. So these two conditions are sufficient for the existence of the Laplace transform. Existence of the Laplace transform is nothing but integration exists. Integral value is exists, then Laplace transform exists, like that we can say. Laplace transform itself a integral transform, right? So piecewise continuous means a function is continuous over the closed interval in such a way that f of t means in such a way that it is defined, it is continuously defined in finite number of subintervals. Means here actually the whole interval is 0 to 5. The whole interval is 0 to 5. But the function is behaving from 0 to 5 as t square and 2t plus 3 as 2t plus 3 over 5 onwards. Okay, that is what piecewise continuous. And exponential function means function of exponential order. A function means a t-domain function with exponential under t tends to infinite is going to be a finite value, is said to be a function of exponential order. If these two conditions satisfy, then Laplace transform by default exists, right? So what are the sufficient conditions of existence of a Laplace transform? It is for short answers. They are asking, university examinations, they are asking for short answers. Have these, just have a look on it and try to understand. You can write in your own words. If you understand, you can write in your own words. Next, Laplace transform of elementary functions. So these Laplace transform of elementary functions is nothing but our formulae. So these are means Laplace transform of t power n is n factorial by s power n plus 1 is defined under some condition, that is n is greater than 0 for n is equals to positive integers or real numbers, positive real numbers. And L of e power at is equal to 1 by s minus a, L of e power minus at is 1 by s plus a, L of sin at equals to a by s square plus a. All these Laplace transform of standard functions is evaluated using definition of Laplace transform, right? So these standard results are used in further doing problems, right? So you please remember this formula. L of t power n is n factorial by s power n plus 1. Okay, L of t power n is n factorial by s power n plus 1. L of e power at is 1 by s minus a. L of e power minus at is 1 by s plus a. L of sin at is a by s square plus a square. L of cos at is s by s square plus a square. L of sin h at is a by s square minus a square. You just list out and look on how we remember these. Just have an hint where it is going to be plus a square, where it is going to be minus a square. Means s square plus a square denominator in case of trigonometric functions. In case of hyperbolic functions, the denominator is a square minus a square, right? So these are the formulae you need to remember for solving the problems. For remembering the problem, just have small hint how to remember. You plan it, right? Next, linearity property. Means here two functions, f of t and whose Laplace transform is a bar of s, and g of t whose Laplace transform is g bar of s. These two functions f of t and g of t is in a linear combination with a constants a and b, whose Laplace transform is a into a bar of s plus b into g bar of s. Okay. So let us see one problem on linearity property. So that is L of e power tt 2t plus 4t cube sin 2t sin 3t plus 2 sin 3t plus 3 cos 3t. So here actually here plus should be a small mistake, plus 2 should be right. I will do here. So here I have Laplace transform of e power 2t plus 4t cube plus 2 sin 3t plus 3 cos 3t we have to evaluate. These are all standard forms that we have listed in previous slide. Using those formula we are going to evaluate, right? So linearity, as per the linearity property, I am just applying Laplace transform to every individual function as they are under fundamental operation, that is plus, under addition. So I am writing this as L of e power 2t plus 4 into L of t cube plus 2 into L of sin 3t plus 3 into L of cos 3t. Right? Means I just applied linearity property. In the previous slide I shown na linearity property. So by linearity property, I am writing this. I am writing this by linearity property. Now you apply the formula. What are the formulas we had here? L of e power 2t. Actually, L of e power at means what we learned. L of e power at is 1 by s minus a. That we had in previous slides, means Laplace transform of standard functions. So then L of e power 2t means 1 by s minus 2 plus 4 into L of t cube. I listed one Laplace transform of standard function, that is L of t power n. L of t power n is n factorial by s power n plus 1. N factorial by s power n plus 1. So in that sense, L of t cube means 3 factorial by s power 3 plus 1. So 3 factorial by s power 3 plus 1, that is s power 4, plus 2 into sin 3t, L of sin 3t. So we had L of sin at. L of sin at, what we had learned in previous slide, that is a by s square plus a square. A by s square plus a square, that I am writing here, a by s square plus a square, plus L of cos 3t means L of cos 80. L of cos 80 formula you take, that is s by s square plus a square. So here a is 3 square, no sorry, here a is 3 square. So 3 into L of cos 80 means, L of cos 3t means s by s square plus 3 square. Okay, now 1 by s minus 2, 1 by s minus 2 plus 3 factorial is nothing but 6, 6 fours 24 by s power 4 plus, this is here also 3, sorry, in the place of a I have to keep 3. So 2 into 3, 6, 6 by s square plus 9 plus 3 into s, 3s by s square plus 9. If possible, you simplify further, which is equals to 1 by s minus 2 plus 24 by s power 4 plus, As here the denominators are like terms, you can add directly. The numerator parts you can add directly as denominators are same. In case of denominators are same, we can add the numerators directly. So 6 plus 3s, 6 plus 3s by s square plus 9, right? So this is what one problem I have come across. I am just evaluating using Laplace transform. These are all totally standard functions, standard elementary functions for that linear operation, and standard functions means Laplace transform standard functions I just took and I explained here, right? Next. Next one is find the Laplace transform of cos 3t sin 2t, which was asked in 2017. University examination, this question was asked in previously, right? So now L of cos 3t sin 2t. Here two trigonometric functions under multiplication. They are in multiplication. But in previously, when they are in addition, we applied linearity property and we went for evaluation. But here, if it is under multiplication, you cannot do so. Whatever we did in previously, we cannot do so because it is under multiplication. So you try to reduce this product combination into subtraction or addition, subtraction combination or addition combination, then you apply Laplace transform. So how we convert them into addition combination or subtraction, then only we apply. Okay. So in such case, what I am doing now, here I am taking, otherwise here itself I will do. So L of 1 by 2 into 2 cos 3t into sin 2t. I am just multiplying by 2 and divide by 2. Okay. So this is a constant 1 by 2 which will come out from Laplace transform. Okay, L of means 1 by 2 into L of 2 cos 3t and sin 2t into sin 2t. Now we reduce into addition format or subtraction format. How? So we have one formula, that is 2 cos A sin B. 2 cos A sin B equals to sin of A plus B minus sin of A minus B. Okay. 2 cos A cos sin B we can write as sin of A plus B minus sin of minus sin of A minus B. Okay. So then you can easily reduce this, means 1 by 2 into L of sin of, means here in the place of A we have 3t, in the place of B we have 2t, that I am substituting. Sin of A plus B means 3t plus 2t is 5t, minus sin of 3t minus 2t is t. Means I converted this product of cos 3t sin 2t into what? Into subtraction. So now linearity property you apply. Now linearity property you apply, that is 1 by 2 L of sin 5t minus L of sin t. Okay, and use so then which is equals to 1 by 2 L of sin AT. I already we have listed sin AT means a by s square plus a square. Na? In the place of a we have 5 by s square plus 5 square means 25. I am writing directly minus L of sin t. Sin t means here a is 1, sin 1t. So a is 1. So 1 by s square plus 1 square, that is 1. If possible, try to simplify. If possible, do simplification, otherwise you leave it, no problem. Right? I will try to simplify still. Okay, I will try to simplify this. Now, which is equals to 1 by 2. LCM is going to be the combination of the denominators, that is s square plus 25 into s square plus 1. Its numerators are 5 into s square plus 1 minus s square plus 25. Its numerators are product of alternative denominators, means 5 into s square plus 1 minus 1 into s square plus 25. Okay, numerators product of alternative denominators, where LCM is in that case. Okay, so 1 by 2. So now 1 by 2 into 5 into s square is 5s square minus s square is 4s square plus 5 minus 25 is minus 20 plus 5 minus 25 is minus 20 by s square plus 25 into s square plus 1. Okay, so this is what? L of cos 3t. This is the answer. Okay, this is the answer. So Laplace transform of this is 1 by 2 into 4s square minus 20 by s square plus 25 into s square plus 1. Right. Next, even similarly you can also do this. L of 3 cos 2t into cos 3t. See, L of 3 cos 2t cos 3t. So as per the linearity property, this 3 come out. Otherwise 3 is a constant, it will come out from the Laplacian operator, means Laplacian means Laplace operation. Laplacian operator, that is cos L of cos 2t into cos 3t. Again you convert, this is under product. So you convert into how we did in previous problem, how you convert this into. So means here it is like cos A. If it is cos A into cos B, if it is 2 into cos A cos B, what is the formula? Cos of A plus B plus cos of A minus B. 2 cos A cos B, cos of A plus B plus cos of A minus B. So in that sense, you write this as, which is equals to 3 by 2, because I am multiplying by 2 here means divide by 2. Okay, so then L of cos, here A, this is A and this is B, like that you take, and the cos of A plus B means cos 2t plus 3t, means cos 5t. Plus cos of A minus B means cos of 2t minus 3t, cos of minus t is again cos t only. Okay, now you take linearity, as per the linearity property, you write L of cos 5t plus L of cos 1t. Okay. So which is equals to 3 by 2 into L of cos 5t, cos AT, s by s square plus a square, that I said, no? L of cos AT, s by s square plus a square means s by s square plus a, in the place of a we have 5 square, that is 25, plus L of cos t, s by s square plus, in the place of a we have 1 square is 1, and simplify. Okay, so which is equals to 3 by 2 into s into s square plus 1 plus s into s square plus 25 whole divided by s square plus 25 into s square plus 1. Okay, so this which is equals to what? 3 by 2 into s into s square is s cube plus s into s square is s cube, that is 2s cube plus s plus 25s is going to be 26s by s square plus 25 into s square plus 1. So this is Laplace transform of 3 cos 2t into cos 3t. Okay. So like this. Of course, this question is a similar model of the previous one. Next question, L of sine of omega t plus alpha, which was asked in 2014 in university examinations. So here, L of sine omega t plus alpha, which is like sine of a plus b formula, sine of a plus b, sine of a plus b. Sine of a plus b formula is sine a cos b plus cos a sin b. Okay, that formula I am going to apply. So in the place of a we have omega t, in the place of alpha we have b. So I just applying sine omega t into cos b, means cos alpha, plus cos omega t into sin alpha. Okay. So here function in t and here is function in t. These cos alpha and sin alpha are independent of t terms. So they will be a constant. So we can say this is a linear combination of linearity property. You apply linearity property, linear combination of functions. So you apply linearity property that becomes, as per the linearity property, L of sin omega t into cos alpha plus L of cos omega t cos omega t into sin alpha. As sin alpha and cos alpha are constants, they will be out from the Laplace transform operation. So which is equals to, again sin at formula you apply, the Laplace transform of omega. In the place of a we have omega, that is omega by s square plus omega square, omega square into cos alpha plus L of cos omega t is s by s square plus omega square into sin alpha. Right. Now you can take, as denominators are same, you can add the numerators directly. That is omega cos alpha plus s into sin alpha by s square plus omega square. Right? So this is how we evaluate Laplace transform in case of sin term given like this. Okay. Next one. See, in powers, if trigonometric functions are in powers, how to evaluate Laplace transform? Right. See, L of, as Laplace transform is provided in terms of elementary functions. So it is not elementary function, it is in, means this is in powers. Non-linear problem means it is not a standard form, elementary form. So you try to convert this higher order term into elementary form. Then you find Laplace transform. How we convert this higher order term into linear form means elementary form, that we see. So here cos cube means one formula I need to quote here. Cos 3t is 4 cos cube t, 4 cos cube t, cos cube minus 3 cos t. So this is the formula we had, 4 cos cube t minus 3 cos t. So from this I can write cos cube t equals to cos 3t plus 3 cos t by 4. I can write now. You can write now that I am just make subject cos cube t from cos 3t formula. From cos 3t formula I am just make subject of cos cube t, which is written by cos 3t plus 3 cos t by 4. That I will write here cos 3t plus 3 cos t by 4. Right. Again you apply linearity property and take linear elementary function formula you take and find. So which is equals to 1 by 4 L of cos 3t plus 3 into L of cos t. Okay. Right. So which is equals to 1 by 4 into L of cos 3t again cos 80 form, that is s by s square plus a square, which is s by s square plus a square. In the place of a we have 3 square is going to be 9, plus 3 into cos of L of cos t, that is in the place of a we have 1 cos 1t. So 1 by, sorry, s by s square plus 1. Okay, so then yes, if I bring common, then what will be 1 by s square plus 9 plus 3 by s square plus 1. Now you simplify it. Now you do simplification. It's very simple. That is s into 1 into s square plus 1 plus 3 into s square plus 9. That is 4s square. 4s square, isn't it? 3s square plus 1s square, 4s square plus 21 plus 1, 27, 3 9s 27 plus 1, 28 by s square plus 9 into s square plus 1. Okay, this is how we do. In case of in case of powers, if elementary functions are happening in powers in higher degree terms, that you convert into elementary term and evaluate Laplace transform. Next, so next is even sin h square 3t, a different function which was also asked in university examinations. Sin h square 3t, it is a hyperbolic function. Even this hyperbolic function is provided in powers. Even you have to convert into simple elementary terms. Then you evaluate Laplace transform. How we do that is L of sin h 3t. Actually, hyperbolic function of sin h, hyperbolic function sin ht is e power t minus e power minus t by 2. E power t minus e power minus t by 2. So here we have sin h square 3t, means first you write down sin h 3t. Sin h 3t means what you get? E power 3t minus e power minus 3t by 2. Having square now, so then put a square. Put a square. That I am doing directly. Okay, so then e power 3t minus e power minus 3t by 2 whole square. By 2 whole square I am taking. Right? As per hyperbolic function definitions, I took that one. So which is equals to L of e power 3t minus e power minus 3t whole square by 4 will come, that I am bringing out, it becomes 1 by 4. It becomes 1 by 4. Okay, so which is equals to 1 by 4. Now you expand it under a minus b whole square formula, that is 1 by 4 into L of e power 3t minus e power minus 3t whole square is e power 3t whole square plus e power minus 3t whole square minus, means a minus b whole square, a square plus b square minus 2ab, that is e power 3t whole square means e power 6t plus e power minus 3t whole square, it becomes e power minus 6t. Okay, minus 2 into a into b, means 2 into e power 3t into e power minus 3t. 2 into e power 3t into e power minus 3t. So these terms get cancelled as they are inverse to each other. they will get cancelled, right? So then which is equals to 1 by 4 Laplace transform of e power 60 plus e power minus 60 minus 2, right? Now apply linearity property. Means whatever the form provided in the problem, you try to convert them into linear, try to convert into standard form functions, then apply Laplace transform. Standard form functions under addition or subtraction made. In addition operation or subtraction operation you convert into, then you apply Laplace transform. Whatever the function it is, you try to convert into. Okay. So then, which is equals to 1 by 4 L of e power 60 minus L of e power minus 60 plus minus 2 into minus 2 into L of 1 I am writing. Minus 2 into L of 1 I am writing. Right. Minus 2 into L of 1. How 1 come? Because this 2 we can write as 2 into 1. If I bring 2 outside, 1 be left. Then what is L of 1? L of 1 you evaluate using t power n, L of t power n. See, we have already L of t power n formula is n factorial by s power n plus 1. S power n plus 1. So, when it becomes 1, if I take 0 in this, if I take 0, t power 0 is 1, then you put 0 here, 0 factorial and 0. 0 factorial is 1, it's defined, no proof. 0 factorial is 1. So 1 by s power 1 is 1 by s. So Laplace transform 1 is 1 by s, that you remember. That is derived from L of t power n equals to n factorial by s power n plus 1. So which is equals to 1 by 4 L of e power 8 is 1 by s minus 6 plus L of e power minus 60 is 1 by s plus 6 minus 2 into L of 1, that is 2 by s. 2 into 1 by s, that is 2 into 1 by s, that is 2 by s. So here you write down L of 1 equals to 1 by s, which is drawn by L of t power n equals to n factorial by s power n plus 1. Now you try to simplify this. You try to simplify this. Right? Use the LCM and accordingly numerator spots take exists. That equals to 1 by 4 into. So this numerator is s, denominator is s into s minus 6 into s plus 6 is going to be s square minus 36. Okay. Now here the numerator will be these two combination s into s plus 6 other than its denominator. Its numerator is other than its denominator from the LCM plus here denominator is 6 plus s plus 6. So its numerator is other than s plus 6, that is s minus 6 into s minus 2 into s minus 6 into s plus 6 is s square minus 36. Now we try to simplify this, which is equal to 1 by 4 s into s square plus s into s square minus 2s square. S square terms are going to be cancelled. Okay, so 6s minus 6s, so this also get cancelled. So this totally terms are get cancelled. Minus 2 into minus 36 is 72 by s into s square minus 36, where 72 is get cancelled by 18 times. 18 times. Therefore, Laplace transform of sin h square 3t equals to 18 by s into s square minus 36. This is the answer. Okay, I am just reducing the higher degree term into a simpler form, in simpler elementary form, and evaluate it, right? Okay, next. So next, linearity property means just up to here we discuss the problems on elementary functions. Up to here we discuss the problems on elementary means basic things, means just it's a short answers type we covered. Now we are entering into properties of Laplace transform further. So using standard forms, how we evaluated Laplace transforms, we done. Now further approach is using properties we evaluate Laplace transforms. Okay, this is further higher order. So one is linearity property we apply, that is already we applied, discussed. So first shifting theorem, second shifting theorem, change of scale property, multiplication by t, division by t, and Laplace transform of derivatives, Laplace transform of integrals, Laplace transform of integrals by Laplace, evaluation of integrals by Laplace transform. So these are the properties we had. Among these properties, which you need to focus more is this: evaluation of integrals by Laplace transform, most frequently asking questions in university examinations. And these combinations, of course, these are tools like for solving problems. You should not avoid any property. The properties which we apply on simplification part. Every property you need to cover. You should not escape. Just a property, it's a problem. One problem we used to do. Then that combine all properties we used to apply in solving differential equations, right? So mostly in properties, evaluation of integrals by Laplace transform, most frequently asking questions. Of course, these are all important to learn. These are all important on evaluation of integrals. Also, these tools we use. Okay. So Laplace transform special functions, on special functions also they are asking. Okay, this second shifting theorem and special functions, some small relation is there that we see further. Okay, next linearity property. So on linearity property we used and these things here. How we adopt the methods for finding or solving problems under Laplace transform? Which method we adopt? Firstly, use standard formulae. If means standard formula means Laplace transform of elementary functions formulas you use, or else you go for using properties to solve a problem under Laplace transform. If not, if using formulae is not possible or using properties is not possible, then you approach Laplace transform definition of Laplace transform. That is ultimate. It's a solution for every problem. So these approaches are shortcut. Okay, formulas, using formulas we evaluate, using properties we evaluate. If that is not happened, you approach definition. Definition is ultimate method, but it is time taking and difficulty you come across. For that, to avoid that difficulty, we use of formulae and properties, right? Next, linearity property that we discussed, change of scale property, right? Change of scale property. So here, if L of f of t equals to f bar of s, if L of f of t equals to f bar of s, then L of at, actually this has to be here, means here I will write change of scale property, L of f of t is equals to f bar of s. Sorry, here some small technical, means some this one get disturbed here. So what I am writing here, okay? L of f of t equals to f bar of s. When Laplace transform of a function with at is going to be 1 by a into f bar of s by a. 1 by a into f bar of s by a. Okay, multiplication by a, then is going to be 1 by a into f bar of s by a. Next, L of f of t by a equals to a into f bar of as. This is change of scale property. Okay, this is multiplication, means with a, f of t with a is division by a in f bar of s, in f bar of. So here division by a is multiplication by in f bar of s, right? This is change of scale property. On this we will discuss the problems. Right. So linearity property, change of scale property that I have explained now. So previously this was disturbed, now I adjusted. So L of f of t equals to a bar of s, L of f of t equals to a bar of s. Okay. Then on change of scale property, this f of when t is placed by at, that 1 by a into a bar of s by a will happen. Similarly for t by a, right? So see this problem using linearity property, means change of scale property, how we do. So here f of t is, here f of t equals to L of f of t, sorry, L of f of t equals to log s plus 3 by s plus 1. Okay, which we take as means, which is a bar of s only. L of f of t is log of s plus 3 by s plus 1 is nothing but a bar of s. Okay. Now I am going to evaluate, means going to find L of f of 2t. T is placed by 2t. So as per the change of scale property, we have 1 by a into, means 1 by 2 into a bar of s by a, that is 2. Where a bar of s is this, then a bar of s plus 2 means placed by s by 2 in a bar of s, which is equals to 1 by 2 into log of s by 2 plus 3 by s by 2 plus 1. I am just placing s by 2 on change of scale property. So which is equals to 1 by 2 into log of s by 2 plus 3 becomes s plus 6 by s by 2 plus 1 becomes s plus 2, as numerator, as denominator of numerator and denominator of denominator is get cancelled on 2 because denominator of numerator is 2 and denominator of denominator is also 2, both are get cancelled and leads this, simplifies this 1 by 2 into log of s plus 6 by s plus 1. Okay, so this is L of f of 2t, which was asked in 2015 in university examinations for short answers. Even competitive exams, they used to ask this type of questions. Okay, you please remember how the scale, change of scale property we apply. Right. Next, so sine root t. Here I am taking here let f of t equals to sine root t. I am taking f of t equals to sine root t. I am taking. Then L of f of t, L of sine root t is L of f of t is equals to a bar of s, which is equals to root pi by 2s root s into e power minus 1 by 4s. Okay. Now asking us to evaluate sine L of sine 2 root t. Okay, L of sine 2 root t. So now we have to find L of sine 2 root t. In the place of root t, used 2 root t, which is equals to 1 by a into a bar of s by a, means s by 2. So in this f bar of s, keep s by 2. So which is equals to 1 by 2 into 1 by 2 into root pi by 2 into s by 2 into root of s by 2 into e power minus 1 by 4 into s by 2. So 2 get cancelled, which is equals to 1 by 2 into root pi. Here we can write this as this total one, root pi by root of s by 2. Root pi by root of s by 2, how we write now? On simplification, you will get this as 2 pi by s under root. Root pi by root of s by 2 is going to be root of 2 pi by s into e power minus 1 by 2s. As 2 divides 4 by 2 times, it leads 1 by 2s. So this is Laplace transform of sin 2t, sin 2 root t. Okay. So these two problems are related to change of scale property. Using change of scale property, how we do it's very simple. Okay. So these properties I am just discussing the properties and the corresponding problems so that you understand the concept and how we use of in future problems. Next one is first shifting theorem. Even this also one important property which we use in further problems. Okay, most frequent use this property. When a function with a combination of exponential, how we evaluate Laplace transform? That we come to know here. Right? See, f of t, here f of t, if it is f of t, we evaluate Laplace transform, that is f bar of s. If it is f of t with a combination of exponential function, how we evaluate? That is f bar of s is shifted to s minus a. If the function with the exponential of e power at, exponential power of a power at, s is shifted to s minus a. If the function with the exponential with negative power, then that s is shifted to s plus a. That's why shifting theorem used to call. That's why it is said to be shifting theorem. If I multiply the function with e power at, then its Laplace transform shifted to s minus a. When we multiply the function with the e power minus at, then its Laplace transform shifted to s plus a. Right? Then see the problem here. E power t into t plus 1 whole square. So t plus 1 whole square is with the exponential term, with an exponential function. Then you should get an idea that is, it's an application of shifting theorem. For shifting theorem, you should get an idea. If the function with the exponential, whose Laplace transform is application of a shifting theorem. Okay? So now I am doing that. So L of e power t into t plus 1 whole square. So here t plus 1 whole square is a higher degree term. It is not in standard form. It is not in elementary form. You try to reduce into elementary form. Then you can evaluate Laplace transform. So then L of e power t, I just expand it for reducing into linear form. So t plus 1 whole square is t square plus 2t plus 1. A plus b whole square I applied, a square plus 2ab plus 1. Just e power means here L of t square plus 2 into L of t plus L of 1. Linearity property I applied. These Laplace transform with a combination of exponential. So by first shifting theorem, this Laplace transform functions are transformed to s minus 1. Why s minus 1? You see here, in previous, you see here, in the place exponential with a, s minus a we have, no? In the place of a we have 1. Nothing is there means 1, no? So, in the Laplace transform function, that is s, means a bar of s, is shifted to s minus 1, right? So, which is equals to L of t power 2, L of t power n that we know, L of t power n. L of t power n means n factorial by s power n plus 1. L of t power n equals to n factorial by t power n plus 1. So, in the place of n we have 2. So, 2 factorial by s power 2 plus 1, that becomes 2 by s cube, as 2 factorial is 2 only, plus 2 into L of t means here 1 we have. So, 1 factorial by s power 1 plus 1. So, 1 factorial is 1 by s square. That is 2 into 1, 2 by s square. So, L of 1 is nothing but t power 0, na? L of 1 is nothing but t power 0. Put n is equal to 0 in this formula. You will get 0 factorial by s power 0 plus 1 is going to be 1 by s. Where s shifted to s minus 1. Right. Now shift s to s minus 1 in this, which is equals to 2 by s minus 1 whole cube plus 2 by s minus 1 whole square plus 1 by s minus 1. Okay, I shifted s to s minus 1 as per the first shifting theorem. Right? Now you simplify this, which is equals to as the denominators are s minus 1 whole cube is the highest degree term in which every denominator is included. S minus 1 whole square include in this s minus 1 whole cube. S minus 1 is also include s minus 1 whole cube. So therefore, its LCM is s minus 1 whole cube only. So on whole, the LCM is s minus 1 whole cube. Then its numerators are what? Here for 2 numerator is its LCM only, so 2 will be as its numerator part plus 2 by s minus 1 whole square. Here denominator is s minus 1 whole square, which is a short of s minus 1. It's a short in s minus 1 to get s minus whole cube, as s minus 1 whole cube is under LCM. So this becomes 2 into s minus 1 plus here denominator is s minus 1, it is short with s minus 1 whole square, so the numerator becomes s minus 1 whole square. So which is equals to 2 plus 2s minus 2 plus s minus 1 whole square, you expand it, s square minus 2s plus 1 by s minus 1 whole cube. Right? So this simplification part you need to do. It's very easy. Okay? So then, which is equals to s square, only term we had, so I am writing s square. Next, plus 2s minus 2s get cancelled, plus 2 minus 2 get cancelled, only 1 will be left in the numerator, plus 1 by s minus 1 whole cube. So this is Laplace transform of e power t into 1 t plus 1 whole square, which is equals to s square plus 1 by s minus 1 whole cube. This is the answer. Right? So this is one problem which regards first shifting theorem. Okay. Next one, e power minus 3t cos h 4t sin 3t. Somehow a multiple combination problem. Exponential term is there. This is exponential term. This is a hyperbolic function. This is trigonometric functions. All combinations, exponential, hyperbolic and trigonometric. Whereas exponential function is there, exponential function combination is there, so it is a by default application of first shifting theorem that you should identify. Right? Now, here L of e power minus 3t. I am going to simplify first. Of course, e power minus 3t is there, so we identify this is a application of first shifting theorem. So now we need to simplify those as a more number of functions involved, make it simple. That is done by simplification, on simplification. So cos h 4t means e power 4t minus e power minus 4t by 2 into sin 3t. It's a definition of hyperbolic function, cos hyperbolic function. Okay. Definition of cos h 4t. Cos h 80 means e power 80 minus e power minus 80 by 2. Okay. So now I am trying to simplify this as by 2 is n that I will bring out by 2. I am bringing out from the Laplace transform, which is a constant. Now e power minus 3t into e power 4t is going to be e power t minus e power minus 3t into e power minus 4t is going to be e power minus 7t into sin 3t. Okay. So which is equals to 1 by 2 into L of e power t into sin 3t. E power t into sin 3t means I am just applying linearity property here, or applying Laplace transform for individual terms, minus L of e power minus 7t into sin 3t. Right? I just took Laplace transform for every individual term. Every individual term is a combination of exponential function. So it is application of first shifting theorem, it's clear. So 1 by 2. So here L of sin 3t, where s is shifted to s minus 1. Okay, because t, e power t with t coefficient is 1, so s is shifted to s minus 1, minus L of sin 3t. Here t coefficient is minus 7, so s is shifted to s plus 1. S is shifted to s plus 1. Right? Now you shift that s into s minus 1 on applying of Laplace transform 1 by 2, 1 by 2, L of sin 3t, L of sin 80, a by s square plus a square. In the place of a we have 3. So 3 by s square plus 9 that I am writing. 3 by s square plus 9 minus 3 by s square plus 9. Okay. So here s is shifted to s plus 7. Okay. So here s is shifted to s minus 1. Here s shifted to s plus 7. So that I will apply here, that you apply. So which is equals to 1 by 2, 3 by s minus 1 whole square plus 9 minus 3 by s plus 7 whole square by 9, whole square plus 9. So which is equals to 1 by 2 into 3 by s minus 1 whole square means s square minus 2s plus 1 plus 9 means plus 10. Plus, if, okay, 3 by s square, s plus 7 whole square means s square plus 14s plus 49 plus 9 is going to be 58, plus 58. Okay, so which is equals to, you take 3 common, that becomes 3 by 2 into, and evaluate its further simplification. Plus this is 10 actually, plus 10 into s square plus 14s plus 58. Okay, so now you simplify its numerators. So as 3 is taken out, 1 will be left. So these numerators are is going to be alternative of its denominators. 14 s square plus 14 plus means s square plus s square is going to be 2s square minus 2s plus 14s is going to be, is going to be 10s, 12s is going to be 12s. So is plus 10 plus 58 is means plus 68. So this is a answer for this question. Right. So which was in 2016, this was asked for a long answer type. Next question is sin 2t cos h 2t. Even this also first shifting theorem application. Of course, here you cannot identify is it first shifting theorem application. So nowhere exponential function present. It's a combination of trigonometric and hyperbolic. When you see the problem, you cannot say is it application of first shifting theorem or second or any other, that you will get doubt. So here these two are trigonometric functions. Whereas this is a hyperbolic function. Hyperbolic function is an exponential function. So a exponential function we can see here. So means here the function is with a combination of exponential function. It is a first shifting theorem application. So likewise, you need to identify the problem. First, read the problem carefully. Identify which property you can apply, which property is convenient to find the Laplace transform, to solve the problem. Right? So now, L of sin 2t into cos t into cos t, wait, So L of sine 2t into cos t cos h2t. We already had an idea about hyperbolic functions. Cos h2t is e power 2t minus e power minus 2t by 2. Right? I converted hyperbolic functions into exponential. And one more thing you need to convert into, is that here trigonometric functions are under multiplication. If the functions are under multiplication, you cannot go for applying Laplace transform directly. You need to convert them into addition of the functions or subtraction of the functions. Then you can go for finding Laplace transform as per the knowledge of, as per the previous knowledge. Right? So here L of, so this sin 2t cos t, I am multiplying by 2 and divide by 2, 2 sin 2t. This type of problems we already come across. Okay, how the functions in multiplication reduces to addition or subtraction of those that we come across. So you will, I hope you are aware of this. Okay, into e power 2t minus e power minus 2t by 2. Right? So this 1 by 2 is a constant, you can bring it out. So 1 by 2 L of 2 sin A cos B, 2 sin A cos B, 2 sin A cos B. Formula is sin A plus B, sin A plus B plus, these are all basic formulae which you, these formulas are familiar. I hope you are familiar with these formulas. You have come across at your plus 2 level, right? So I am writing this as sin of A plus B is sin 2t plus 1t is sin 3t, sin 3t plus sin 2t minus t is sin t into e power 2t minus e power minus 2t by 2 is there, and that 2 also bringing outside becomes 1 by 4. So which is equals to 1 by 4, 1 by 4 so here you apply L of e power 2t sin 3t plus sin t minus e power minus 2t I will write this as so L of e power 2t, this function, minus e power minus 2t means L of, I have to write here. Wait, I have to write here. So L of e power minus 2t into sin 3t plus sin t. Okay. Okay. So now you simplify this. So which is equals to 1 by 4, 1 by 4 L of, so this 1 by 4 is common for the total term. So L of sin 3t plus L of sin t. Okay, for this S shifted to S minus 2. For this S shifted to S minus 2 because these two terms are with the combination of e power 2t. So S shifted to S minus 2 minus L of sin 3t, L of sin 3t plus L of sin t. Here S shifted to S plus 2. S shifted to S plus 2 as this is combination with e power minus 2t. Right. So now, so which is equals to 1 by 4, okay, into so L of sin 3t is 3 by S square plus 9. 3 by S square plus 9 plus L of sin t means, sorry, not S, S. So L of sin t means 1 by S square plus 1. 1 by S square plus 1. Okay, here S is shifted to what? S minus 2. S minus 2. Right? Next, minus L of sin 3, again you write this one, 3 by S square plus 9 plus 1 by S square plus 1. So in this, S is shifted to S plus 2. S is shifted to S plus 2. Okay, in this S is shifted to S plus 2. Close the bracket. Right? So then which is equals to 1 by 4. First, before going to shift S to S minus 2 or S to S plus 2, simplify first. So 3 into S square plus S square, 4S square. Of course, need some much simplification part here. Much simplification part you need to do. As you provide the answer in simplified form, that evaluator easily identify that you did correct. Okay, you try to simplify the thing. Evaluator can easily evaluate your script. So 3s square plus 1s square is going to be 4s square, right? So 3 into 1, 3 plus 9 is going to be 12. This is the simplification part for s square plus 9 into s square plus 1, where s is shifted to s minus 2, where s is shifted to s minus 2. Where s is shifted to s minus 2. Why it's gone? Which is equals to 1 by 4 into what I did here. Okay, here we have s minus 2, sorry, s shifted to s minus 2 minus, so even here also we will get the same 4s square plus 12 by s square plus 9 into s square plus 1, where s is shifted to s plus 2, where s is shifted to s plus 2. Where s is shifted to s plus 2. Sorry for the, and proceed for the simplification. So which is equals to 1 by 4. Now you substitute 4 into s minus 2 whole square plus 12 by s minus 2 whole square plus 9 into s minus 2 whole square plus 1 minus even here also 4 into s plus 2 whole square plus 12 by s plus 2 whole square plus 9 into s plus 2 whole square plus 1. You try to simplify this. Simplify this. This part I am just leaving to you. Right? Next, multiplication by t. Next property is multiplication by t. So previous property, if f of t means if the function is with exponential function, if the function is with e power at, then how we evaluated Laplace transform we learned. If it is the function with the t square or t cube, in such case how we do that? So this is, if f of t is with t combination under multiplication, if the function f of t is with the t combination under multiplication, whose Laplace transform is going to be minus 1 whole power n into nth derivative of f bar of s. Okay, so here n times nth means t power n, t power n multiplied to f of t, then the corresponding nth derivative with minus 1 power n will for f bar of s. Let us see the problem. So t sin at, which was asked in 2014, means sin at is multiplied by t. So here t power is 1. So then L of t sin at, which is multiplied by t power 1. So which is going to be minus 1 whole power 1, because t power 1 is there now. Okay, so means if t is having odd powers, so minus with the negative sign. If it is having even powers, positive will get, positive. So then power 1 means single derivative, d by ds of f bar of s. So here let us take f of t equals to sin at. let us take f of t equals to sin a t. Its Laplace transform L of f of t equals to L of f of t equals to L of sin a t. So as per the elementary functions, Laplace transform of elementary functions, we write this as a by s square plus a square. So which is f bar of s, which is f bar of s. Okay. So now on evaluation of Laplace transform of t into sin a t is equals to minus 1 whole power n into minus into d by ds of a by s square plus a square. D by ds of f bar of s. F bar of s is a by s square plus a square. So now, where a is constant, you can bring it out, minus a. D by, if a comes out, means 1 by s square plus a square will be left. So whose denominator, whose differentiation is minus 1 by s square plus a square whole square, and s square plus a square differentiation is 2s into 2s. Okay. 1 by s square plus a square differentiation is minus 1 by s square plus a square whole square, and s square plus a square differentiation is 2s. On simplification, you will get 2as by s square plus a square whole square. This is the Laplace transform of t sin a t. Laplace transform of t sin a t, which is asked for short answers. Okay, which is asked for short answers. Right. Next, let us see some more problems on this. So t into cos square t. So it's a combination of t. So here cos square t is provided, which is not elementary function. Try to convert into elementary function and apply t multiplication by t and apply multiplication by t. So then L of t cos square t. So which is equals to, again, minus d by ds of, directly I am putting in sign only, as t is having odd power, means 1. So negative sign I am taking, d by ds of f bar of s. D by ds of f bar of s. Okay. So here I am taking, here let us take f of t equals to cos square t. So here I am taking f of t is equal to cos square t. So cos square t is not in terms of elementary functions. You try to convert into elementary functions so that we can evaluate Laplace transform, right? So in that sense, I am writing cos square t as 1 plus cos 2t by 2. Cos square t formula, which is evaluated from cos 2t. Okay. As we know that cos square t equals to 1 plus cos 2t. I hope you are all aware of it. So now you find out L of f of t equals to, when I am taking Laplace transform to this, L of 1 by 2 into L of 1 plus L of cos 2t, L of cos 2t. I just apply linearity property for this. I am taking Laplace transform and apply linearity property. So then L of f of t is nothing but f bar of s, which is equals to 1 by 2 into 1 by s plus cos at is s by s square Like that we have, no? S by s square plus a square. So s by s square plus 4. 2 square is nothing but 4. So which I am simplifying, otherwise leave it like that you put. Because further simplification you need to use here this. If it is in simple terms, the differentiation happens happily. If you make simple, the terms will be very clumsy, on differentiation will get confused. Okay, it's not, it's a middle of the solution, no. It's further simplification is required for differentiation. So you please like this, you keep and go for things here, right? So then means this f bar of s I am putting here, so which is equals to minus d by ds of this 1 by 2 into 1 by 2, otherwise so 1 by 2 into 1 by 2 into why it is happening. So 1 by 2 into, so 1 by 2 into, why it is happening, that a technical issue seems, pen technical issue it seems, sir. Technical issue. ఇది పెన్ను ఇది అవుతుంది. Wait a minute, students, there's some technical issue here. Just wait a minute, I will come back. Okay, I will continue here. So minus d by ds of 1 by 2 into 1 by 2 into 1 by s plus s by s square plus 4. Okay, so which is equals to minus, you bring out to 1 by 2, then d by ds of 1 by s is going to be minus 1 by s square plus s by s square plus 4. Quotient rule, division on quotient rule you apply, that is s square plus 4 into 1 minus s into s square plus 4 differentiation is 2s by s square plus 4 whole square. So which is equals to minus 1 by 2 into minus 1 by s square. Now you simplify, s square minus 2s square is going to be minus s square and plus 4 by s square plus 4 whole square. So now you take minus common, it becomes 1 by 2 into 1 by s square plus here as I am taking minus common, minus s square plus 4 becomes s square minus 4 by s square plus 4 whole square. It is enough. No further simplification. If you want, you can proceed. It's enough, no problem. We can give it off. Okay, mostly we did simplification at last. So make it stop. Okay. So today this is this session is going to be closed. Again tomorrow, same timing 7 to 9. The session will start from here. So make use of these sessions. We are all, not only mathematics, all engineering subjects are conducting. You try to make use of for your end semester examinations, for your university examinations. Okay, guys, please take care. Thank you and have a nice day. Right.